Alrighty, math magicians, here we go. We're going to learn something new here. We're going to follow along in our textbooks. It's in section 7.9. So let's title it Note. Lesson 7.9. And your textbook calls this factoring special products. Now this is a little new, so you may need to pause the video, possibly rewind it or re-watch it if necessary until you learn it. Okay, so let's just remember a couple things here. Let's go back and let's review quickly something like this. When you have two binomials that are almost identical, except one's an addition and one's a subtraction, you could double distribute or FOIL, or maybe you've memorized that this turns into x squared minus 81, right? The middle term drops out. If you don't believe me, go ahead. X times x is x squared. Yep. This would be a negative 9x, and then a positive 9x, so those turn up. When you add negative 9x with positive 9x, that's 0, so it drops right out, and then you get negative 81. Okay? All right, let's just, another one. Let's say you had 2x plus 5, the quantity, times the quantity of 2x minus 5. All right, there you go again. They're almost identical, except for one is addition and one is subtraction. So you could double distribute or FOIL, or this is a shortcut worth memorizing. Just square the 2x. 2x times 2x is 4x squared. And then square the 5. 5 times 5 is 25. And make it subtraction. Alright, so you supposedly already memorized that. Now, we're going to go backwards. Okay? So now we're going to actually go backwards. So we're going to factor what's called the difference of perfect squares. Difference of perfect squares. And this is kind of one you need to actually end up memorizing. All right, so it's the difference of two perfect squares. So here's an example. You might have x squared minus 16. And you got to factor that. Okay, so look at it. Difference means subtraction. So there's subtraction. And perfect squares. This is a perfect square because x times itself, x times x is x squared. And this is also a perfect square because 4 times itself, 4 times 4. X times x, 4 times 4. Difference. Oh, this is a difference of perfect squares. It will factor into two binomials. And it's going to be x plus 4 and x minus 4. Where did I get x? Because x times x is x squared. And where did I come up with 4? Because 4 times negative 4 is negative 16. And remember, with this kind, when one's plus and one's minus and they're almost identical, there's no middle term. Now let's try another one. So this is just a pattern that is worth memorizing. Okay, you might have 9x squared minus 16. Okay, this is a difference. It has to be subtraction. This has to be a perfect square. It is, because 3 times 3 is 9. X times x is x squared. And this has to be a perfect square. 4 times 4. Okay, I know that it's going to factor into two binomials. The first is going to be 3x plus 4. And the second one's going to be 3x minus 4. Where did I get 3x? Because 3x times itself is 9x squared, and 4 times 4 is 16. We want one to be plus, one to be minus, because there's no middle term. Number 3. Oh, let's go with 81x squared minus 100. Okay, it's a difference. And are these perfect squares? Yep, because 9 times 9 is 81. X times x is x squared. And 10 times itself, 10 times 10 is 100. Great. We can go right to the two binomials. 9x plus 10, 9x minus 10. When one is plus, when they're almost identical, and one is addition and one is subtraction, there won't be a middle term. And if you double distribute this and FOIL it out, you'll end up right back here. Okay, number 4. Let's try a couple more. Oh, how about 16x squared minus 25? Oh my goodness. I think that is a difference of two perfect squares. Perfect squares. 4 times 4 gives you 16. 5 times itself. Those are perfect squares. Ah, I've memorized this. 4x plus 5 times the quantity 4x minus 5. All I'm doing is finding the square root. What's the square root of 25? 5. What's the square root of 16? 4. All right, let's try just a couple more. Okay, what about this? How about number 5? Let's go 5x squared minus 121. All right, it's a difference. That's a perfect square because the square root of 121 is 11. Uh-oh, this is not a perfect square. Nothing times itself gives you 5. This is not a difference of perfect squares. It's a difference, but not of perfect squares. This is unfactorable. Okay, let's try number 6. What if you have x squared plus 9? Okay, perfect square because x times itself. Perfect square, 3 times itself, 3 times. Not a difference. This is not a difference. This is unfactorable. All right, last one like this, number 7. Let's go with 20x squared minus, let's go with minus 80. No, let's see. Let's try something else. Okay, no, let's keep it 80. Whoops. Okay, this is a difference, but they're not perfect squares. But wait, is there a GCF? Oh yeah, we're always supposed to look for a GCF. So what's the GCF? How about 20? Yep, I can factor out a 20. And I'll have x squared minus 4. Okay, now wait, you might not be done, because look right here. Difference, because it's subtraction. Perfect square, x times itself. Perfect square, 2 times 2. Okay, so you keep going. You write 20. And then a difference of perfect squares always turns into one addition and one subtraction. And you fill in with the square roots. Square root of x squared is x. Square root of 4 is 2. All right? Okay, there's one other thing I need to help you out with. So this would be part C. So let's just look at a trinomial. And we've been looking at trinomials quite a bit, so we should be getting pretty good at it. Let's say you had x squared plus 8x plus 16. Okay, this is a trinomial. It has a leading coefficient of 1, so we can do this one a little quicker. If you do your x, you need AC, a times c there, and you need the factors to add up to b. So a times c is 16. and b is 8. So what multiplies to give you 16 and at the same time adds up to 8? Isn't that 4 times 4, right? Doesn't 4 times 4 give you 16, and when you add 4 and 4 you get 8? Okay, so since this has a leading coefficient of 1, I can go directly to my factored answer. It's going to be x plus 4 and then another x plus 4. Oh, they're both the same, so a better way to write that would be x plus 4 entire quantity squared. All right? Let's try one more. All right, number 2. This should be our last one. Let's go with 12x squared minus 36x plus 27. Okay, if you look carefully enough, there's a GCF in this trinomial. So we're supposed to always look for that first. And there is a GCF. And I believe the GCF is 3. So we'll factor out a 3, which means divide by 3. We get 4x squared minus 12x plus 9. Okay, this is a trinomial. So we'll go with, we need to know what a times c is, and we want the factors to add up to b. So a times c, 4 times 9 is 36, and b is negative 12. So what are the factors of 36 that add up to negative 12? I believe that has to be negative 6 and negative 6. Because negative 6 times negative 6 is 36. A negative times a negative is a positive. And when you add a negative 6 with another negative 6, you get negative 12. All right. Now we can't just go right to our factored answer because this has a leading coefficient of 4, not 1. So I have to continue with the British method, 4 blanks. So here we go, 4x squared, positive 9, minus 6x, and another minus 6x. All right, what do these two have in common? What can I divide both of these by? I believe 2x. And that will leave me with 2x minus 3. And when I look at these two, I believe I can factor a 3 out. I think I want it to be negative 3. Yes, because a negative times a positive would be a negative. And a negative times another times a negative times a negative would be a positive. Yeah, so that's going to work. See? Negative times positive is negative. Negative times negative is positive. And we have a match. So I bring down this 2x minus 3. That matches. And what's left is another 2x minus 3. And then don't forget this GCF at the beginning. Bring that down too. And then a better way to write this would be 3 times the quantity, 2x minus 3, and then that quantity is squared. All right, feel free to re-watch this if you need some help. Good luck.